Okay, so after this Bessel and Legendre functions, now we are going to talk about another kind of a special function. These are all called as a special function. So this is one of the special function. There are many more, but so far we talk about the Bessel, then we talk about the Legendre. Now we are talking about another kind of a special function. That is what we called as an Hermite function or Hermite polynomials हम इनको बोलते हैं. Now what actually are these Hermite polynomials and why do they arise? Why we need them? They, as though they are not as that of importance that we have of Legendre and for the Bessel differential equation, but these Hermite polynomials are also used in the physics. For example, if you talk about the solution of a harmonic oscillator problem is a very important problem in the quantum mechanics. And if you if you solve the if you will find the solution to that Hermite simple harmonic oscillator, the solutions of that simple harmonic oscillators are actually the Hermite polynomials. Okay, so this the importance before finding the solution. So I will tell you this Hermite polynomials, Hermite polynomials, or I must say that Hermite functions, they are the solution to the Hermite differential equation. I'm going to write this Hermite differential equation in a while, but these Hermite polynomials, as I said, occur in the solutions of simple harmonic oscillator, simple uh, harmonic oscillator of this quantum mechanics. Okay. So this you are going to study in, I think, in second semester, the harmonic oscillator problem, and there you will see that you will require these Hermite polynomials and the Hermite differential equations. Okay, so what is this Hermite polynomials are actually the solutions to the Hermite differential equation. Thus this Hermite differential equation, in short I will write SDE, Hermite differential equation, has the form like y double prime minus 2xy prime plus 2ny. This is Hermite differential equation. If you look at this particular differential equation, it seems very simple differential equation as compared to your Bessel and the Legendre differential equation, right? Okay, now we have to solve this differential equation. And how we solve these kind of a differential equations? This is a second order differential equation, and we will try to solve this by the power series. Okay? Or I must say the series solution to this particular differential equation, right? How we find the method is very similar which you are doing for the last few cases. So I will start with the series solution. The solution is given by the series solution or the power series. So you know that the solution that I will say that y is equal to some summation over some m running from 0 to infinity cm x raised to power m plus r. Okay, I'm saying that let y is a solution, power series solution to this differential equation. The solution will be like c0 x raised to power uh, some when m is 0, so it will be x raised power r plus c1 x raised power r plus 1 plus c2 x raised power r plus 2 plus so on. Anyways, you are not supposed to write it here, but I will do it at the end. Okay, then we need to find out this r values and also these coefficients c0, c1 and c2. So you know the method, we are doing it for so many problems. So once taking the differentiation of this equation, so the differentiation with y prime, you know that it's summation some m running from 0 to infinity cm m plus r x raised to power m plus r minus 1, right? Again differentiating it with respect to x again, so y double prime will be equal to some summation m running from 0 to infinity cm m plus r into m plus r minus 1 x raised to power m plus r minus 2, right? Okay, then what is the next step? We substitute this y prime and y double prime in this particular equation, in this equation first. You can name this as equation first. Okay, so once you will substitute all these in this particular equation, so I will write down the equation here. let me write it on the next page. So you will say that uh, y double prime plus uh, sorry minus 2xy prime plus 2ny is equal to 0, right? Okay, so now the solution will now, the equation will now become summation m running from 0 to infinity cm y double prime m plus r into m plus r minus 1 into x raised to power m plus r minus 2, right? Can write it like this. Okay, minus twice again summation over m running from 0 to infinity cm m plus r, then x raised to power m plus r minus 1 plus 2n summation over m, okay, cm x raised to power m plus r is equal to 0. So this particular differential equation will become this. Now I can just rearrange it a little bit because I have uh, twice. This is remain as such. Uh, this is 2x, I think. 2x, yes, this is 2x. Okay, this is 2x. So once you will multiply it by x, it will be m plus r. So this coefficient, this term, this x is for m plus r. So I will just combine these two equations. Or I can write down this equation as summation m running from 0 to infinity cm m plus r into m plus r minus 1. Then we have this x raised to power m plus r minus 2. Okay, uh, minus, I will write down this as twice summation over m, summation over m running from 0 to infinity, this cm m plus r minus n. This 2 again I am taking it out, minus n, minus into minus will become plus, this will be 2n, then x raised to power m plus r is equal to 0. I just combine these two terms. So this is like this. Okay. Now this is my equation and I will find out my initial equation and the reconciliation, this equation from this very equation. Now initial equation, you know, initial equation is used to find the roots of the equation, that is to get the values of the r. And the initial equation for this case is obtained by equating the coefficient of, is obtained by, you already know these things, that's why I'm little fast, is obtained by equating coefficient of the lowest power of x, the lowest power of x to 0. The lowest power of x here is x m plus r minus 2 when we are going to substitute m equal to 0. Okay, so what will this? So the coefficient of the lowest term is x raised power r equal m plus r minus 2 is equal to 0. So it will become, when m equal to 0, it will become c0, m is 0, so it will be r into r minus 1, m is 0. Okay, and then we have this c0 x raised power r minus 2. Okay, so this is not equal to 0. C0 I'm writing it here, or I can write it like this. Okay, or so which gives from this thing, which gives us this r into r minus 1 is equal to 0, because this is the coefficient, so implies r is equal to 0 and r is equal to 1. Okay, so we need have the two different values of, so double root, we have the two different values of r. Okay, now we will take two different cases. For r equal to 0, the one solution will correspond to r equal to 0, the other solution will correspond to, because this is a second order differential equation, it will have the two independent solutions. Okay, now before moving to the end, now I will see the powers of the next power of the x. So the next power of x from this term, the coefficient of the next power of x, next power of x is, that is by equating, putting m equal to 0. Yani next power of x, we have to take the coefficient of the lowest term by making m equal to, m equal to 1. Okay, so the coefficient of next power of x is, the coefficient of next power of x is, that is c1, m is 1, so it will be r plus 1, it is m is 1, so it will be r simply. Okay, this will be equal to 0. कोफिशिएंट खाली मैं इसका लिख रहा हूँ m plus r minus 2 का Okay. Now since so this from this particular equation, you know that r is 0 and r plus 1 can never be equal to 0. R plus 1 it is not equal to 0 for any value of r. Agree? Whatever the value you will give to r, it's not equal to 0. So it implies the c1 may or may not be equal to 0. Okay. So I will say that this coefficient c1 may or may not be 0, because r plus 1 is not equal to 0 in any case, but in the case in another case it may be 0. ठीक है, so we will या तो ये 0 होगा या नहीं भी होगा. That is what I mean, may or may not. Okay, so this is about the c1. We will write down the solution including this c1 equal to 0 and not equal to 0 in both the cases later on. But before that, we will try to find out the another thing that's what we call as a recurrence relation. Okay, fine. Okay, before I'm not going to move. Initial equation आप याद रखिएगा. We have the roots r equal to 0 and r equal to 1. Okay, I will write it here. We obtain two things. One is that this root from the initial equation, and other is by comparing the next power of the x, we may say that this c1 can be or cannot be 0, or it may or may not be equal to 0. Now then we have the reconciliation. Okay, the reconciliation can be found by equating the general term x raised power r plus s. You know that reconciliation, that is by equating coefficient of x raised power r plus s. Coefficient of x raised power r plus s. So how we can make the x raised power r plus s? By putting m is equal to s plus 2 here, it will become r plus s, and m is equal to s, right? So this part will become then when m, so here m is equal to s plus 2, and here m is equal to s in this term. Okay, so this equation will now become c s plus 2. Okay, m is s plus 2. So I will write r first, r plus s plus 2 into s is equal to 2. So it will r plus s plus 1. Okay, cs plus 2, right, minus twice cs, r is, it will become r plus s minus n. Okay, this is equal to 0. Equating coefficient of this to 0. Okay, now just simply I will just rearrange the term. I will write down this cs plus 2 here. Cs plus 2 will be equal to, when we are going to take it, it will be twice r plus s minus n divided by r plus s plus 2 into r plus s minus plus 1 cs. Yeah, you can write down this as, I will write it on the twice r plus n minus 2n. So I will write down this as, or you just write it here, c s plus 2 will be equal to twice r plus s minus twice n divided by r plus s plus 2 into r plus s plus 1 cs, right? Okay. Okay, fine. So okay, now we will consider two different cases. Case first is when r is equal to, when r is equal to 0. So when r is equal to 0 in this equation, so I can find out these coefficients. Okay, first I will write down this equation. Then so cs plus 2 will be equal to 2r is 0, it will be simply 2s minus 2n divided by r plus s plus 2 and r plus s plus 1. Okay, fine. So now, sorry, r is 0, so it will be simply s plus 2 and s plus 1. I will not write r here, s plus 2 and s plus 1, because it will make the equation little simple to find out the different values. Okay, now for even terms, I will consider for even terms, what are the even terms? That is, for example, C0, 2, 4. Okay, for S is equal to 0, this will be C2 will be equal to C2 will be equal to S is equal to 0. It will be simply minus 2n divided by 2 into 2 into S is 0, 2 into 1, right? 2 into 1, then C0, right? ओके या आप इसको ऐसे लिख सकते हैं -2n divided by 2 factorial c0. Okay, for another even term s is equal to 2, it will be c4. So c4 will now be equal to, okay, s is equal to 2, so it will be 4 minus 2n, right? So it will be 4 minus 2n divided by, this is s is 2, that is 4 into 3, then c2. But c2 we already know that this will be, I can write down this as 4 minus 2n divided by 4 into 3. This c2 is minus 2n divided by 2 factorial into c0. Okay, so now you can take 2 throughout common. So I will write down this as 2 raised to power 2. 2 raised to power 2, यहाँ से मैंने 2 एक बाहर लिया और यहाँ से 2 मैंने एक बाहर लिया, 2 2s are 4. So then it will be here 2 minus n, sorry, n, पहले मैं n लिखूंगा, n into n minus 2, this n into n minus 2. Okay, this 4 into 3 into 2 factorial, that is 4 factorial c0. ठीक है? Similarly, you can find c6. So what is c6? C6 will be now 2 raised to power 2, so it will be 2 raised to power 3, right? But it will be another term will be minus, because I'm just obtaining it in terms of a c1. This term will be minus, this minus will make it plus. Okay, now it will be 2 raised to power 3 n into n minus 2 into n minus 4 divided by 2 this is 4 factorial, so this is 6 factorial, so this will become 6 factorial, then c0. Okay, and so on and so forth. So if I will ask you what will be the general term, so the general term here now will be c6 के बाद, so the general term will be or c2m. So m 2m इसलिए मैं ले रहा हूँ because we are taking the values like 2 into 0, 2 2s are 4, 2 4s are 2 3s are 6. So all these values. So this c2m is general equal to, it will be minus 2 raised to power m. Just look at these equations, this and this. So this is one is other minus, other is plus. So when m is 0, so when m is even, it will be plus. When m is odd, it will be minus. So I will write down this as minus 2 raised to power m, n into n minus 2, n minus 4, so on up to n minus 2n plus 2 will be the last term divided by, this is 4 factorial, this is 2 factorial, 4 factorial, 6 factorial, other will be 8 factorial. So it will be simply here, what is there? So it will be 2m factorial. Okay, so we have find out this coefficient. Now we are going to take the another case. The case second is, okay, now before going to take the case second, we have obtained the this coefficients, and I will find out the another coefficient if c1 is not equal to 0 for two different cases. Okay, uh, this is for even terms and for odd terms. For odd terms में आपका क्या चाहिए? For example, this is s is equal to 1, so this will be equal to now c3, s is 2 plus 1, that is 3, c3. Okay, this is 2 minus 2 into n, 2n divided by, okay, this will be again r is s plus 2, so s is 1, so 1 plus 2, it is 3 into 2, 3 into 2, or I can write down this as 2 into sorry, okay, 2 into n minus 1, 2 into n minus 1, but minus 2 into n minus 1 divided by 3 factorial into c1, c3. Similarly, c5 will now be equal to, for s is equal to, यहाँ पे for s is equal to 3. So this is 2 3s are 6, right? 2 3s are 6 minus 2n divided by 5 into 3. okay, into C3, but C3 we already have found, that is equal to, so I will write down this as n minus 3. This will be minus 2, अगर मैं बाहर ले लूं, -2 raised to power 2, -2 raised to power, यहाँ से एक 2 और यहाँ से that's -2 raised to power 2. okay, यहाँ पे क्या हो जाएगा आपका, this will be now n minus 1 into n minus 1 into n minus 2, sorry, not n minus 2, n minus 3, because this is 3, n minus 3 divided by, this is 5 into 3 into 3 factorial, sorry, this is 3 factorial, 3 into 2. Okay, so 5 into 3, this is 4, 5 into 4. So 5 into 4 into 3 factorial, that is simply 5 factorial. Then we have the C naught. Similarly, you will have the C7, C8, C9. So I will just write down the general term here. So जैसे मैंने यहाँ पे लिखा था C2M, I will write it here. Now I have M plus 1 for all terms. So I will write down this as so on. You can similarly, you can write down C7, C9. So I will write down as C2M plus 1. C2M plus 1. This will be equal from this term. It will be now minus 2 raised to power M. And this N minus 1.
क्या ये ऊपर होगा ना C1 C0 की जगह?
हाँ ये C, obviously this C1. हाँ ये C1 है. So N minus 1, N minus 3, so on up to N minus 2M plus 1 last term. 2M plus 1th term, then 2M plus 1 factorial, because we have 5 here, 5 factorial, we have a term 2M plus 1, so this 2M plus 1, 3 factorial, then C1. So this is the general term. So you can obtain all these coefficients from this, right? Now I say this C1, C1 जो मैंने कहा था, this may or may not be equal to 0. So if let us suppose the first case this is equal to 0, if C1 is not equal to 0, केस अगर C1 0 नहीं है तो सॉल्यूशन कैसा होगा फिर? Okay, so now I have find out the coefficient of C1 and C2, and you know that the solution to your given differential equation is like y is equal to summation over m Cm x raised to power m plus r. R is 0, so it is the solution is simply C0 x plus C0 plus C1 x plus C2 x square plus C3 x cube plus C4 x4 plus so on, इस तरह से. So now I will just break it into two different parts. One is the even terms and other is the, like I have the solution. So the solution will be, you will write if C1 is not equal to 0, then if C1 is not 0, then our solution will include the terms including these odd coefficients C1, C3, C2. Okay, so then the solution will be y will be equal to, from this solution let us write down the first even term. So it will be C0, what is the coefficients जो हमने find किए हैं, C2, C4. So the first is C0 minus, that is C0, and then we have minus C0 is common, another term is 2n divided by 2 factorial x square plus the second term is 2 raised to power 2 n into n minus 2. जो हमने कोएफिशिएंट सभी किए थे C4 और C6 तक हमने फाइंड किए थे, 2 raised to power 2 n minus 2. Then we have divided by 4 factorial x raised to power 4 plus so on. Okay, this is C1 plus C1. C1 the first term is x, C1x, ये वाली term C1x plus, okay, minus the second term C3 जो है, that is minus 2 into n minus 1 divided by 3 factorial x cube, ये वाली term. इसके बाद x5 वाली term आ जाएगी, वो plus है. Okay, plus that is 2 raised to power 2 n minus 1 into n minus ये वाली term, to n minus 1 into n minus 3 divided by 5 factorial into x raised to power 5 plus next term will be then minus so on. So this is the solution if C1 is not equal to 0. So I will now consider the case if C1 is equal to 0. if C1 is equal to 0, if C1 is equal to 0, then the solution will simply be this, because C1 will make it all these terms 0. Then the solution, then y is equal to, then the solution, that is y is equal to C0, okay, 1 minus 2n by 2 factorial x square plus other terms, and I will say let that be equal to y1. Say the first solution is y1. Okay, quickly, I want to finish the second case before this meeting will end. We have some 8-10 minutes. Okay, this is the case first when r is equal to 0. Now simply we have the case second. Case second kya tha? When r is equal to 1. So when r is equal to 1, I will write down the reconciliation cs plus 2 again, twice s plus 1 minus 2n divided by s plus 3, then s plus 2. From the reconciliation, this is cs. Now in this case, when r is equal to 1, c1 is always equal to 0. Now c1 is equal to 0 implies all other this c3 is equal to c5, so on, they are all equal to 0. So we are not going to find out these odd coefficients c1, c3, c3, because this can never be equal to 0. That implies c1 is always equal to 0, right? Because r plus 1 can never be equal to 0. Okay. So, so let us try to find out these coefficients. So let us s is equal to 0. C2 will simply be equal to, from this equation, s is equal to 0. It will be 2 minus 2n divided by, again, this is 3 into 2, that is 3 factorial C0, right? Or you can write down minus 2 agar main bahar le lo, n minus 1 divided by 3 factorial. Then we have the C0. Okay. Now C3, C4 will simply equal to, now again, we already have found, so I will write this as 2 raised to power 2 n minus 1 n minus 3 divided by 5 factorial C naught. Okay. Similarly, I can have the C6. What is C6, by the way? It will be 2 to power 3 n minus 1, right? N minus 1, but this term will be minus now. 2 to power 3 n minus 1 n minus 3, then n minus 5 divided by 7 factor. So yes, 7 factorial n plus 1, 7 factorial C naught. Okay. So in general, what could be the next last term? General term C twice m will be now equal to minus 2 raised to power m n minus 1 n minus 3, so on up to n minus 2m plus 1, because we have these kind of terms, n minus 2m plus 1 terms, divided by 2m plus 1 factorial C0. Okay, so we have find out all these coefficients. Therefore the solution kya hoga? So the solution y now for this particular case will be equal to, c1 is 0, so we will simply write the solution will be now like c0 plus c2 x square plus c4 x4 plus so on. Yahan se solution up, c0 is x, c0 humne bahar liya, so it will be 1, c2 is ye, so it is minus 2 into n minus 1 divided by 3 factorial. Then we have the c0, okay, x square, okay, the another term c4, that will be now plus c4 is this, plus 2 to power 2 n minus 1 n minus 3 divided by 5 factorial x raised to power 4 plus some other terms, sorry, we have x raised to power r plus 1, we have x raised to c0 x raised to power r plus 1, r1 hai na, so it will become c3, this will become c5. Okay, so this will be cube and this will be 5, because the solution is y is equal to summation over m cm x raised to power m plus r is 1, so it will be y will be equal to corresponding 0, x raised r is 1, so it will be c1 x. Okay, ये वाली term भी यहाँ पे x हो जाएगी यहाँ पे, this is x. Okay, so it will be c0x plus, now when m is equal to 2, it will be c2 x raised to power 3 plus c4 x raised to power 5. This will be the solution. So c0x. So यहाँ पे c0x minus 2, this will be the solution, and I will say that let that be equal to y2. Okay, so we find out the two different solutions. एक तो ये आपने solution find किया corresponding to one of the root. Then I find out the another solution, that is this, जिसको मैंने y1. So I'm saying that this solution is equal to this y1, this particular solution y1. So now the general solution. So the general solution अगर हम की बात करेंगे तो the general solution y double prime Hermite differential equation minus 2xy prime plus 2ny is equal to 0. So we find out two different solutions, y1 and y2. Then you know that the general solution is always given by a y1 plus b y2. Okay, a and b are two arbitrary constants. Y1 we find out corresponding to or equal to 0, and y2 we find out corresponding to r equal to 1. So this is the complete solution to your Hermite differential equation. Okay? This was the simplest of all the examples which we have taken so far. That's why I was little fast, because you can follow these steps. Actually, I was not supposed to do it for you. You could have done it yourself. I was supposed to talk about directly from the legend, this Hermite polynomials. But I thought, let us revive it so that those there are certain students who are complaining that we are we are facing some problems in solving this kind of to find out the serious solution. So I thought that will be a revision to them. Okay. uh, okay, the meeting will end in a minute or so. If you have any question or something to ask, you can. या कोई point इसमें समझ में, then we will just join the another meeting for this Hermite polynomials. Again 10-15 minutes for the Hermite polynomials. शाबाश, है किसी को? If you have to ask any questions, you can ask. Okay, is it okay? Burhan, where is Burhan?
Yes, sir.
Is it okay? It's simple. You have done a lot of exercise on all these things, so you just find it. Okay.
Yes, sir.
Now I will talk about the Hermite polynomials, but for that you need to join another meeting because it is going to end. Okay, so I'm just stopping here this meeting. Just join quickly.